Hi, I'm Brandon Bloom. I'm going to be talking about CircleCI's frontend, which is built in Om, and we'll talk a little bit about it. In this talk, we'll first give you a little introduction to CircleCI, talk about some things in the before time, before Om and I came to this project. We'll talk about the architecture of CircleCI's frontend. We'll talk about our experiences with that architecture, and then I'll ramble a little bit about like kind of the future of it and the landscape with Om and front-end work in ClojureScript. So before I get started talking about that, I first want to give credit where credit is due. I basically had nothing to do with this. These two guys deserve all of the credit. Yeah, so Daniel and Danny here, the engineer and designer who did the bulk of the work on this, and they're now working on a new cool startup that's also in Om and ClojureScript called Precursor App, which is like a real-time collaborative prototyping thing for teams. And their work is based on Omacha, which is like a very early example app done in Om to experiment with architectures using React from ClojureScript. But there's and there's a ton of other folks who have at least one commit in the code base. So this is just people who have helped make CircleCI's front end better. It is open source, so there are a whole bunch of other folks who have participated. Let me tell you a little bit about CircleCI. It is a continuous integration server, and it is deeply integrated with GitHub. It helps you ship better code faster by making sure that all your builds and changes that go to GitHub get built through the integration, like all your unit tests run and everything. And Circle's product is really simple, and that's important because it means that our UI is really simple. And so I'll show you a little bit about the UI. Here's the dashboard. It's, as you'd expect, just a list of recent builds, and you can see in the navigation bar on the side, there's the projects you're building. You can see all the build status, and you can drill into an individual build. And here you can see some details about the build. You can drill into individual actions in the build. This is all real-time updated. As your builds are running, all the log data is being fed down to the browser, and that's pretty much the app. From a UI perspective, well, sort of, really. I mean, it's the details that make apps hard, and if you've ever worked on a really high-quality production front end, you know that all the little details take a ton of time. But getting the details right are why customers love your product, and so that's why Circle spends a ton of time on the front end doing things like this. This is, you made an error in your config file, and we show you the lines that failed and give you details and point you to documentation. And getting all of that right is a ton of work. And so even though the app feels really simple and small, there's a lot of code that goes into all the little bells and whistles. But there's also a slog of other things that you just have to do when you're building a web app, right? You've got various screens for settings and configuring billing, and you've got forms for picking out different stuff, and you've got all sorts of authorization things to deal with, and it's just a lot of stuff that needs to get built, and Om helps us do that better. So what were we doing before Om? Well, I don't know, I wasn't there, but I did a little digging in the code, and I realized that if we look at the tech that's involved in the front end, so server-side and client-side, but not talking about the back-end storage and everything, just talking about what it takes to build the user interface. The dark ages here, we were pretty vanilla, right? There was Ruby, there was Rails, and Rails does all sorts of other stuff, but we used all those things to serve HTML on our front end. And then on the client side, we had Backbone and CoffeeScript and all these awful things. But this is the best we had, and we should all take a moment to appreciate how far we've come in the last couple of years in the front end space. Like now we're in the age of enlightenment. We've got stuff like Clojure, that's cool, and all these simpler tools. But on the front end side, in the client, we've got ClojureScript. We store most of our data in a Clojure atom. We use core async to coordinate things. We use a bunch of simpler stuff, not the least of which is Om and React and those things. And so the question is, now that we've made this switch from Rails and Backbone, is it awesome? Are we happy with this? Are we glad we've done this? And the answer is, yeah, it's pretty awesome. But not everything is awesome. So what I'm going to do is I'm going to give you a tour. We're gonna look through the code, the major sections, kind of look through it, and kind of get a feel for what works, what doesn't, and help you maybe structure an app if you're going to use Om for a real production system. So briefly, we'll start our tour with the client-server pieces. Basically, at Circle, we don't have any private APIs. Our UI is built on all the same public APIs that you guys can use for interacting with our backend. This is really great for dog fooding your public APIs, but it's less than ideal for some of our user interface needs. Sometimes we need to do an extra request here or there. If you're gonna make a public API as part of your product, then it pays to go this route to dog food your own APIs. But if your public API, if your API is not gonna be part of your product, it kind of makes sense to actually tune your API for the actual application UI you're building. So we're going to skip the other stuff on the server side that you all are familiar with, and we'll talk about the client side. So as I said, Om, ClojureScript, and it's all open source. So you can download, build, run against the production backend and contribute to CircleCI's frontend. Or if you're just curious, if you just want to see what a real, proper, like in production Om app looks like, this is a great place to start. Or you can look at a smaller kind of toy-sized app in Omacha, which has more or less the same architecture I'm going to talk about today. And it's a sizable project, but it's manageable. We're talking, sub 30,000 lines of code, 13 or so thousand of that is ClojureScript, 10,000-ish of that is just style sheets. So really, it's pretty manageable, and I'm going to kind of give you the roadmap of where to look and see what parts do what. So the architecture is basically, you have the server, and we have these things that we call controllers talking to the server. And what the controllers do is they basically operate on a queue, and they process data, they talk to the server, and then the various controllers swap into a big global atom. This might sound familiar if you've been listening to all these React talks and Om talks. So we swap into the big global atom, that's our app state, and then we render the big old atom with our views. And then the views then put things back on a queue, and they go back into the controllers, and the cycle repeats. So this is the top level of the code base, and it's pretty flat. In the top level, we have some of the main functions and other things that kind of kick the whole system off, and other utility libraries and things. The real interesting stuff to get started if you're following the flow is to go jump into the controllers directory, which is where all the events are processed, and all the coordination between network requests and the UI occur. And then in the models directory, you'll find data functions that operate on the information requested from the API and from the controllers. And those aren't your typical models. Like, we don't have model objects. They're all pure data functions. They all operate on Clojure literals. And then the components directory has all the views. So this is where you'll find all the Om bits. So the interesting thing is that these are all glued together with the app state atom. And so let's talk about the atom a little bit. The good thing about the atom is it's debuggable, right? All your values are Eden. You can print them, you can read them, you can serialize them, send them across the wire. It's very simple. What you see is what you get. You put data in the atom, you get data out of the atom, no magic happens. And it's really easy because you don't have to think about it that much. You can just put data in the atom, and you pull data out of the atom, and it's just as you'd expect. And so this is sort of a massive step forward compared to something like Backbone. And we've all been singing the praises of this approach, and it works pretty well for a Circle. The thing is that there are some bad sides to the big ol' atom. And frankly, the biggest thing is that it's anti-modular, right? Every view has to agree on the shape of the data that's going to be living in that big ol' atom. And that is tricky because it's talking to the server, which is a different idea of what the shape should be, and then some view may want some different slice of data. And it's also complex because it means that the API requests you're making are going to be tightly coupled to the view you have. So this requires discipline to manage at scale. You actually have to be pretty careful about what goes where in the atom, and you have to take stock every once in a while of the schema of this big atom, because it's all implicit, and you have to keep it straight between the various parts of the system and the various views within a part of the system. But it gets a little worse, too. The other problem with this atom thing is that you sometimes have a conflict between fetching from the server and rendering performance. You want to fetch extra stuff in a larger batch to minimize the round trips and maximize the value you're getting from the bandwidth to and from the server. But then you have to slice the data up, because if you give too much data to a particular view, you're going to lose all those nice Om optimizations about equality and whatnot for the view. You give it a big ton of stuff that it doesn't care about, and you overquery, the view's going to re-render even though nothing it actually cares about has changed. And this also means that you have to denormalize stuff and put it into various places in the big ol' atom to make sure that you get the right slice of data to the right view. And so this starts to take on the flavor of sort of like a shared file system, or maybe like a build system makefile of doom that you've experienced at one point in your career. And if you're careful, it's not so bad, but if you're not careful, this can get out of hand. So let's talk more about the controllers, though. If you go down into the controllers directory, you'll first see that there's very few of them. The very first one of interest, that's kind of the entry point, is the navigation controller. The navigation controller is responsible for requesting all the stuff from the server, subscribing to the various real-time update channels, and then kicking off initial renders. And then what happens is the API controller will handle all the responses that come back in from the server and collate those responses into the big atom and cause re-renders to happen. Then the controls will put messages on a queue and update. They'll go into the queue. The controls controller, which is a bit confusing, will process those things and then again update the big atom and move on with the view. And then lastly, there's the WebSocket controller, which those subscriptions that come in that are made when the page is loaded, they're going to listen for some incremental change and then again update the app state. So what's worth noting here is that this is sort of separated by technology, but in reality, everything's driven by that navigation controller. The very first thing that happens is you issue a bunch of requests and then set up and coordinate using core async all the different pieces and reactions that are going to happen, and then you render your page, and then you handle the things that happen after page renders, like button clicks and stuff. So let's slice this differently. So this is sliced by technology. Let's look at it by a particular view. Here is a really simplified version of the pseudocode for the page load of the build page. It shows you a particular build that you've run on our servers. This is actually pretty similar to the actual thing that does happen, and you can go find where I copy paste and chopped out the pieces to simplify it to fit on a slide. This is more or less the idea. When you navigate to the build page, you put a message on the API channel, say, go get the build data. You subscribe to the build updates channel. That's a server-side push notification channel. And then you set some optimistic state, like the breadcrumbs. You set some ID values for the as of unyet queried information, like the current organization or repository from GitHub that the build is coming from. And then in the API controller, when an event comes back in on that queue, you say, okay, we downloaded the build data, so now we associate that in the key places, replacing the temporary data that was there. And that's how you get the nice loading experience in the UI there, is you basically check, is the data present or not? And then as things happen to the build on the server side, we push changes down to the WebSocket channels, and we update the state there as well. And so that's basically the lifetime of a page modulo user interaction, which takes us to the control controller, which is where you have something that we have explicitly named events for different things that can happen. So here you have something like a control event. When the retry a build button gets clicked, we do an optimistic update. We say the build has been queued, which we don't know if that actually happened or not, right? We're assuming that the API event will succeed. And then based on success or failure or various states of this, we'll update the atoms with the information as it comes in or subscribe to other channels. But it's important that all of the events we handle go on a queue like this, and they're always data. And that's pretty important. We'll talk about why in a moment. So like I said, these controllers are page-centric. And this works for us because our app is page-like. It's not really app-like. We don't have menu bars, and we don't have complex interactions and documents you operate on. We have places you go, and when you go to that place, you get a batch of data and subscribe to a set of channels. So if your application isn't like that, this architecture may not be right for you. I said it's the data slice is wrong. It's organized by technology. It really should be organized by what page you're looking at. It's a little problematic. You have 4 or 5 controllers open at once. I think they're multi-methods. We probably can just pivot them. I don't know why you haven't yet. But like I said, this also requires that you have this. This also plays nice with the big old atom thing. And so it may or may not scale to an application that has a very large number of pages, unless you just kind of give up on having pages share data and caching things, or come up with a better solution there. But it works quite well for the limited number of views we have. And being centralized is a blessing. All the data comes in as objects we can read and print. And so we have global logging for every action that happens in the UI, which is super valuable for debugging. It's also super valuable for auditing. So we can look at one place and see, here are all the API requests that are happening. So we know basically visually, by looking at the code, whether or not there's a good chance the page will render quickly, which is important. A lot of times you do things where you have some implicit queries happening and your site is slow, and then you look at the timeline graph and you're like, oh, okay, it made 50 requests, where are those coming from? Having all the API requests be kicked off from the same spot and collated centrally means that you can audit it very easily, and that's very important for keeping your site snappy. But there's a downside to this as well as, and I've talked about again with the Atom, is that you don't have any isolation between your components. So you have to be careful that everything on a particular page cooperates. So if you have a component that you reuse on multiple pages, you have to do extra work to isolate it. We don't have too many reused components. The ones we do are pretty simple, like a button or whatever. And so this hasn't been too big of a problem for us, but it could be an issue in an application that has a lot more reusable little bits and parts. The other thing is that the controllers are non-deterministic. So they use core async. They talk to the network. There's latency. That's a thing. And so we use core async to tame the non-determinism of the network. And we make sure things come in the right order and we coordinate them. But this also inadvertently introduces some non-determinism into our UI. We do not use core async in the Om layer, in the views, directly in the message callbacks at all. Because core async is a tool for managing non-determinism, and our views are deterministic. And so this is really important, and we used to use core async all over the app, and we've since pushed it back into the controller layer, and whole categories of bugs have gone away. And then the ones that remain, we can track down with the global logging, which is really nice. So back to the components themselves, speaking about those, if you do this little grep here, which is the two main ways we create components in our code, there's 179, my last count, things that get rendered as components. So that's a lot of stuff. These all vary in complexity. There's some little tiny ones that just render a little stuff. There's some really big ones that do a ton of work. But they more or less all follow this same pattern. And you guys have seen this before. This is an Om view. This is using Sublano, which is a hiccup-style template language. So here you have a view, you take some data in, you reify the Om interfaces, you pull some information out of the data, you calculate some derived values, and then you render a template. And in the template, you hook up some event handlers to your DOM nodes. And in this case, we use this raise function here, which is basically the only side effect that our UI ever has, which is it queues a message fire and forget. Raise returns nil. We don't do any thinking in these callbacks. In fact, we probably could come up with a syntax that wasn't a function. It was just the value there. We probably should do that. We'd have to change Sublano or whatever. But we do not put code in those callbacks unless we really have to for some dirty hack. This is, again, to get that global logging. And so most of our views are pure components. They assume the controllers have prefetched all the data, so they basically are really simple functions of the input data. They don't do a lot of work to think about what they need to render. They say they get some value in, they get some value out, and we're pretty judicious in our use of component local state. And I've already hammered on this point of putting all the callback stuff on a queue. But anytime we violate these basic principles, we try and package it up into a component that has component local state, that does whatever evil DOM interop voodoo it needs to do, and we'll package it up as something that is in fact reusable. So a button that manages, clicking states, or something that has to do with drag and drop, or these other stateful transient interactions, we can try and isolate them as quickly as we can. And the thing is that component local state is actually really useful. I disagree with some of the other purists who are like, we need to eliminate component local state completely. I've actually written about component local state and how you can make it pure automatically. There's a blog post linked at the bottom there. And I think David Nolan's talked about this a bunch, and this was demoed in the CircleCI front end where we can have components with component local state. We mount all of that component local state into the global atom, and we can serialize everything, including the component local state, across the internet, which is super useful for debugging. So even though those components are impure, we're able to use all of Om's intercession features to kind of force them to be pure by redefining those side effects. But don't be afraid to use these features. Just use them carefully and keep them encapsulated and isolated and into purpose-built components. Because whenever you're doing things that are effectual and stateful, you're basically building systems. And you don't want to be in the business of building systems. You want to be in the business of building pure functions of data to views. And so when you do have to build something that has interaction system, use these things, but keep them packed up. I want to take a brief aside to talk about markup. Syntax really does matter. I'm not really sure why it matters, but it does. People care about this. Danny, the designer who did a lot of this work, used to write Haml, and now he's like, I love Hiccup, it's great, or whatever it is. He's super into it. It's important that designers can work on these things. It means that you get faster iteration and all this important stuff. And so even though there is some pros and cons to the various ways that Reagent or Om and whatever build and create their components, it is important to us that we have that hiccup structure so that it feels like HTML for the design folks. And unfortunately, we lose a lot of the benefits of being data thanks to React. React will break, like once your stuff becomes a component, React breaks the ability to read and print and serialize those things, which is unfortunate. And if we had a more, like if we own the infrastructure there, we could do something more Clojure where those things stay symbolic as opposed to become opaque objects. And also we want to ideally have something that normalizes primitives, user-defined components, and functions into a common syntax so that we can refactor more easily. If you have something that is a component and becomes a function or whatever, you shouldn't have to rewrite your code just because you decided to use a piece of state or because you decided to add an optimization. So markup is something that is still not quite right. It's important we have it. It's not exactly set up right yet. So let's see, on our tour, where were we? We've talked about the server side, we've talked about models, controllers, views, we skipped over builds, and we got to talk about styles still. So let's talk about builds. They're no fun. Even at a CI company, builds kind of suck. We're hoping to make it less sucky for you. We take that pain, but it still takes 80 seconds or so to build our entire front end. Like a clean build. Incremental builds are much better, and we're also on a pretty old version of Om, and David's probably like shaking his fist at me somewhere. This stuff is really improving a lot, but having all this magic on top and all these cross compilers and all these things is not free, and this does get really painful, especially when you have teams and changing dependencies and all that sort of stuff. But asset builds are an issue. Like I said, incremental builds in ClojureScript are faster, the Google Clojure compiler is still a little too slow, but we really want a better asset pipeline. We don't just build ClojureScript, we also build style sheets, and we build images, and we build all sorts of different things, and SVG, and we don't have a really good story here. We're using a library called Stefan, which was designed internally. It is also open source, but it's sort of died a little bit. It's not really being maintained. It was trying to replace sprockets and other stuff from the Rails world. We really do need a build-on-demand, HTTP-friendly asset pipeline system that is ClojureScript friendly. And now that the ClojureScript compiler and all the other folks working on great tooling are getting the foundation in place, I'm hoping somebody will step up and produce like a world-class asset build pipeline for the ClojureScript community. And lastly, we have to talk about styles in terms of our tour. Styles are friggin' terrible. So we use less. This is basically the state of the art right now is preprocessors. This is just CSS with concision. It's shorter. It's not really any different than CSS. Like all it's saving you is typing. And we have all this like great modularity that we've gained in our components of the view layer. And we don't have that in styles. And so this is, I disagree with earlier somebody said that like the fetching data from the server is the final frontier. That's not true. The style modularity problem is like the one thing that we haven't figured out yet. And we only have not suffered from this because Danny was doing such a great job on the styles. And once you add more people, this becomes really hard. And so we're not really sure what we're going to do about this now that we have like more and more people coming to work on the front end, especially being open source and everything. And I guess that basically concludes the tour of all the technologies on our front end, the architecture, etc. I also promised that I'd pontificate a little bit. So I want to harp more on this modularity thing. We're on a quest for modularity in our UIs, and we've come a long way in the front-end space, especially thanks to React. We're starting to see some more stuff. We're starting with the databases getting pulled into the front end. So this was the desired architecture. This is the architecture we had before, and the desired architecture we want is to shrink this down into an individual component and then build a tree of those where we take the whole architecture we have now and this great big atom and squish it but then also be able to do global optimizations. So with React, we can get global optimizations by doing equality checks on our diffs or whatever. Well, we can also do global optimizations for our data fetching. We don't have to rely on the fact that we've centralized on a page basis all of our data fetches. So where we want to be is we want to be in a client database situation where all of that non-determinism with the network is packaged up into a nice little database, and then all the components fetch that data on demand, and then again put all their actions onto a queue, and the whole thing goes in a cycle of cycles of cycles. This may look familiar. This is Facebook's Relay. I live in the future, so I already know this was going to happen. And basically, all of that I was saying in the desired architecture is crammed into that little components block here. Those are the trees. And this is the model that they're talking about. They have the server that is intelligent about the client with sticky sessions. They service GraphQL queries that look a lot like Datomic Pull API request. They fill in a local data store of the social graph in their case, but whatever data you're going to want in your case. That then drives rendering in the recursive tree. All those things put actions onto a queue. They do optimistic updates, which we talked about. They go back to the server, and the whole cycle goes around. This is a brilliant, brilliant design. This needs to happen in the Clojure community, and it's actually kind of sad we haven't done it yet because we have all of the technologies and ideas and ways to think about it and do it, and it'd be so much easier and better with ClojureScript's data structures than you could ever do in JavaScript. We just need to, as a community, get on this because this is the way things should work. But I want to put in a word of caution here, which is that when you do this and you make things more modular, there are sacrifices and trade-offs you have to make. And you don't want to rip out the heart of Om and the heart of the Circle architecture that we're doing, which is the fact that everything's transparent and everything is just pure data. When you get encapsulation, right, you lose transparency. And so like I said, when you have those React views, they're opaque. And we want them not to be opaque. We want them to be debuggable, inspectable, et cetera. And React recovers that by giving you a little plugin in the inspector where you can drill in and see the props and stuff. But we shouldn't have to do that. We should be able to have our modularity cake and eat it too with all the transparency we've come to expect. And so we want to be able to have externalized, serializable, printable, readable, debuggable, transparent state. We want all of our events in a log that's queued, that is data, that's inspectable, that's auditable. And we don't want to suffer from all the brain dead stuff that encapsulation has typically brought with it by making your data hidden behind an abstract interface. So I think that the Clojure community, especially now that we've had some exposure to how great this React model can be, I think that we're uniquely positioned to take the experiences from products like CircleCI and their front end, from all the great work that's happening in the various different ClojureScript libraries out there, and repackage those ideas in the flavor of Clojure with all the wonderful other products going on and build something that is an order of magnitude simpler, an order of magnitude faster, and an order of magnitude easier than a typical front end. We have all the pieces. We got to put them together. And when you have all those modular components that have global optimizations on render, global optimizations on data fetch, that talk to the server in a way where you don't have to be carefully figuring out whether you have a REST API, and if I return 200 or 30 whatever, who cares? We should be at a point where we can build UIs that are fast, that are beautiful, that are modular, that many people can work on, that can be updated, that are reliable, and we need nothing more than the tools we already have in Clojure. And so I think we can do that as a community, and I'd really like to talk to anybody who's working on it. And beyond that, that's basically all I really wanted to share. Circle's product's cool. The code's out there. Go try the product with your GitHub projects and that run their unit tests. It's free to get started, and I think free for open source projects. There's all sorts of cool stuff going on with the open source project. You can contribute. There's bugs to fix if you want to add features. The team's really responsive. Send them an email, chit chat with them. They're hiring, and tell us what you think of our architecture. Come talk to me and tell me how you think we can reach that vision of a modular and simpler and faster front-end architecture. And I want to hear about the projects that you guys are doing there. And I thank you for listening.